Psychologist Dr. David Eagleman is about to conduct the first ever scientific experiment to explore whether time really does slow down in a near-death situation.
So in order to measure how fast people's brains are taking in information, we've built this device, which we call the perceptual chronometer. And the idea is that numbers flash very rapidly on this LED screen. They flash so rapidly that a normal brain under normal circumstances can't see what's being flashed here. But if time were running in slow motion, then you should be able to distinguish the numbers.
Jesse Callis has volunteered to be our guinea pig.
Can you see that there are numbers flashing on the screen here?
Yes.
Okay, these are flashing at a slow rate. If I speed this up, at some
First,
point...
David has to make sure that Jesse can't read the numbers when time is running normally for him.
That it's very difficult to read what the numbers are.
Yes,
Maybe impossible.
very difficult.
Okay, and so are you able to read what's on the screen now?
Yes.
How about now?
Yes.
Okay. And here, can you read the number at all?
No, not at all.
Okay. There's no way to fake this test because if time is not running more slowly, they can't see the sequence.
Whew, it's great.
Jesse, did you see any numbers on the display?
Yeah, 56.
56. All right, let's verify this. Okay, the number that was actually presented was a 5 and a 0, 50. The 0 happens to look a lot like a 6. So what this means is that, at least mostly, he was able to see a presentation rate that he was not able to see under normal circumstances. Maybe what we can do is try again and see if you get both the numbers right this time.
96.
96? True.
That's what I saw.
The answer is 98. Hey, that's great.
So, for a second time, Jesse has seen a number very similar to the one on the screen.
These results today are very encouraging because this is the first evidence that somebody's brain can speed up and they can see the world more slowly during a high adrenaline situation.
I have just invented a perceptual chronometer. And this is it. This device will allow scientists to measure the perception of the passage of time in humans in a life and death situation. Now, the way it works is we take data... Okay, actually that's not my perceptual chronometer. This is, but before I show it, there's an experiment on the perception of the passage of time. And somebody made a video, so you ought to go watch it first. But I object to the way that they have conducted their experiment. I don't think what they're measuring is actually what they think they're measuring. No, they tried an experiment on a rat, and they gave it uppers and downers, and of course the rat's perception of the passage of time was altered. You know, who would have thought? But that was a reasonable experiment. Now, I don't know if there's a problem with having some people take uppers and downers, you know, for the experiment, or I don't know. But at least they could have had some people do some exercises, or maybe read a book, play a video game, watch TV, and then measure their perception of the passage of time. Similar to the rat, had to press a button every 60 seconds, or every 5 minutes, or half an hour, whatever it is. And that would be fairly entertaining. You know, if somebody's waiting at an airport, you know, they might think that 10 minutes, 10 minutes is 30 minutes. You know, I've been waiting here forever. But anyway, the experiment that these people have done, they have built a device, and it is similar to this one. Now, what they have done is they have dropped somebody from a height, and they have put a device on the guy's arm, and they will show a number. When they drop the person, supposedly, they will perceive time goes much slower, therefore they're able to take in more information, and they will be able to read numbers off of this device, whereas before, when the passage of time was being perceived normally, they couldn't read the numbers. Well, the way the experiment worked is that they would flash a number, let's say 42, and then they would flash the opposite of the number. And when they flashed it very quickly, the number would of course blur and you wouldn't be able to read it anymore. The problem with that is is that I have a similar device, and you'll see that it is flashing. It is actually flashing colors instead of numbers. And if time was to speed up or slow down, you would actually be able to determine which colors are being flashed. And to do that, I'm going to do that right now. There, now you can see the colors that are being flashed. Does that mean time is proceeding faster or slower, or your perception of it? Probably not. You're probably not in a life or death situation. You're okay. Now you're not. Now you can see it. Now everything's going crazy. Okay, now you can't see it again and time's returned to normal. Actually, I can determine, you are not able to determine it because the camera's missing some frames, but the persistence of vision, that's what it's called, I'm able to determine that it is blue, green, red is the order of the colors. Of course, when I hold it like this, I'm not able to see the order, or much less the colors at all. So what is the problem of their experiment? Well, if you show the number in the inverse, and if you shake it around a little, then it's pretty obvious that you are able to see the number come out of that blurred image. And so there it is. All he was measuring was the guy shaking the arm, and he could pick the numbers off of it. If he would have added some noise in the background, it would have been much more difficult in order to perceive the number, because when you shift it, it would add too much noise to it. So anyway, that's the experiment. It actually doesn't show anything to have the blinking number and to move it, and then you're able to pick it up. So dropping the people is actually what induced the effect, but not from a change in the perception of time. The eyes and the brain were not able to pick up more information. It's just that it was spread out spatially instead of temporally, so that the brain could read the number from the data that it was seeing. So that's all that there was really showing. It wasn't a very good scientific experiment.